Breaking news! Local Villanova student has just been located 3 weeks after missing report was filed. We now bring you this very special moment where Gabby is reunited with her parents for the first time in weeks.
Mom! Dad!
If you don't mind, I'm going to take her aside for an interview. Okay, Gabby. So how did you get into contact with the outside world? Can you point that a little closer to the camera?
I tried to contact someone by holding up this rescue sign for weeks, but it didn't work, so I ended up floating it down a river nearby.
What happened to your phone?
It's okay. Let's do CPR.
Don't die on me now! No! Oh, I see. It's in a better place now. Anyways, how did you make that sign with no pen in sight?
Do you really want to know?
Yes,
Can you handle the truth?
I think so.
I will tell you under 4 conditions: food, water, a shower, and the chem lab.
We just wanted the audience to know.
There were no Colombos hurt or harmed in the making of this video.
So John, what is the German word of the day?
First off, it's Johann, and my German word of the day is Tugendhauptschaft!
Miss, what's the chemistry word of the day?
Electron delocalization.
Michael, do you have any message for the grade 12s?
Well, I'm so good at chemistry, I know all about it from grade 1 to 12.
What grade are you in?
6.
Okay, so if you're so good at chemistry, what does the element Na stand for?
Oh, that one's an easy one! Nah!
Because it'll be terrible.
I had to figure out natural sources of dye that I could find in the forest. I found blueberries, strawberries, raspberries, which are all wild. I also took some autumn leaves off the trees. Each of the berries and each of the leaves have their own pigment that give them their own unique color. Before we can get right into the specifics of each of the dyes, we first must understand a little bit of organic chemistry. First things first, a phytonutrient is any type of chemical made by a plant. Often, they will have antioxidant properties and have many other health benefits for humans. However, they are not essential for human health. If you aren't sure what an antioxidant is, don't worry. An antioxidant is a molecule that helps to prevent cell damage caused by free radicals. And a free radical is a molecule with an unpaired electron that roams freely in our bodies in search of its missing electron and ends up destroying healthy cells in the process. Now let's get back to pigments. Polyphenols are a type of phytonutrient found abundantly in nature, and there are 2 types, flavonoids and carotenoids. Flavonoids are the pigments found in almost all fruits and vegetables and are responsible for their vibrant colors. Carotenoids, on the other hand, are specifically responsible for their orange, red, and yellow pigments. But what do all of these long and complicated terms have to do with these berries and leaves right in front of me? A lot. All of these raspberries, blueberries, and strawberries contain an organic molecule called anthocyanin. This molecule is responsible for the intense blue and purple color and red colors that you can clearly see. If the fruit is acidic, like the raspberries and the strawberries, the anthocyanin will turn the berry red. If the fruit is more alkaline, like the blueberries, the anthocyanin will turn the berry a blue-purple color. This is the structure of anthocyanin. It is composed of 3 carbon rings, 7 polar functional groups, and an oxygen ion. What I'm drawing right now is the basic structure of an anthocyanin. The R's you see are places where the functional groups, methoxy and hydroxyl, will exist. And the glucose exists at the 3 position with respect to the oxygen ion. Anthocyanin is also attached to a glucose molecule. As you can see, this molecule is quite polar, and so it will be hydrophilic. It also features a lot of resonance and electron delocalization. Have you ever noticed that an unripe fruit has less color than the ripened version? Here's why. As you saw from the previous structure, anthocyanin features a glucose molecule. In unripe fruit, there is a low concentration of glucose, and so very little pigment shows. As the fruit matures and more glucose becomes concentrated inside it, the glucose will attach onto a sugarless molecule called anthocyanidin, which is the same as anthocyanin but without the glucose. This will make anthocyanin, and the pigment will gradually increase in intensity. Now let's talk about leaves. Now let's get serious. We have all experienced the beauty of fall leaves in the autumn season, but have you ever wondered how and why fall leaves change color and fall off? Essentially what happens is that as the days get shorter and nights get longer, the plant's leaves will detect this based on the amount of sunlight they get per day. The cells at the junction between leaf and stem then begin to divide rapidly, leaving a loose clump of cells called an abscission layer. This clump of cells cuts off the passage of major macronutrients like carbohydrates from stem to leaf, and also stops chlorophyll production. If you don't already know, chlorophyll is the green pigment in leaves. As a result, the underlying red, yellow, and orange pigments are able to show, and the leaves fall off. Through the process of photooxidation, the bright pigments in the leaves are broken down, and only the brown pigments called tannins are left. Honey can be used to preserve the color in the leaves. The 2 pigments responsible for the colors in autumn leaves fall under the carotenoid polyphenol category and are called xanthophylls and carotenes. The xanthophylls are responsible for yellow, and the carotenes are responsible for orange. The xanthophylls responsible for the yellow color in the yolk of an egg are called lutein and zeaxanthin. And you've probably already heard of the carotene that's responsible for orange in a carrot. It's called beta-carotene. Pretty good. As you can see, the xanthophyll structure features a series of carbon rings, hydrogens, 2 hydroxyl groups, and 6 methyl groups. Its chemical formula is C40H56O2. Carotene, on the other hand, also features a series of carbon rings, and it has the hydrogens and methyl groups, but it does not have the polar hydroxyl groups. Its chemical formula is C40H56, making it a very fatty hydrocarbon, which makes it nonpolar. So, xanthophylls and carotenes are quite similar in structure, but xanthophylls are more polar due to its additional hydroxyl groups.
We now interrupt our regularly scheduled programming for a brief message from our sponsors.
Oh, sorry. Didn't see you there. Do you struggle to see the board in your classroom? Is life passing you by in a blur? Then purchase our new beta-carotene supplement called VitaCare. When your body takes in beta-carotene, it's converted to vitamin A, which is essential to maintain eye health. Please call 1-800-CARROT in the next 20 minutes to get a free sample of VitaCare today.
Now we know all about the different types of pigments and dyes that are present in the berries and leaves in front of me. But how are we going to harness these dyes and actually write with them? Wood, and thus tree bark, is made of cellulose, a polysaccharide that we humans cannot digest because we do not make the enzyme called cellulase to do so. Cellulose is a polar molecule as it features many polar hydroxyl functional groups in its structure. We all know the phrase like dissolves like from grade 11 chemistry, but in case you've forgotten, it means that only substances with like polarity will interact. This concept is highly important for what we are about to do. Because cellulose is polar, and because we learned before that all our pigments are also polar, except for carotene, that means that they will be able to be absorbed by the cellulose, and each molecule will be able to bind to the cellulose by way of hydrogen bonding, especially between the polar functional groups. This is the same reason for why your paper towel can absorb liquid spills and why you can get grass stains on your cotton shirts. As you can see right over here, when we put our berries on the paper towel, it actually stained it. So you've got a purple stain over here and a red one over here. And for the strawberries, you'd have to cut them open first to see the dye. So the polar pigment that's in the berries has hydrogen bonded to the polar hydroxyl functional groups in the paper and has turned it purple and red. And over here, with the leaves, you can see that some of the yellow pigment has actually gone into the paper towel as well. Once you've picked your medium to write on, you must choose a medium to write with. Now, sticks are obviously very abundant in the forest, and a sharp one can be used. You can also use the tip of a bird feather that has fallen on the ground, if you can find one, as its pointed tip will be effective, and you'll look cool writing with it. And if all else fails, you can always just write with your own finger. In the paper was very effective at absorbing the dyes. The raspberries smudged more due to their shape, and the blueberries were easiest to use.
And so, I used my knowledge of all of these concepts and methods to create my sign for recipe.
Now here I am. That's amazing. I never thought that these chemistry concepts like capillary action and polarity would save my life one day. What's even more surprising is that we see these concepts every single day of our lives. The very clothes I'm wearing are made of cotton, which contains cellulose, and that is why dyes are able to stay in it so well. Every time anyone writes with pen and paper, the ink in the page is able to stay there because of polarity. And when you write with a marker, it bleeds through the page due to capillary action.
Wow, I never thought of it that way. Thanks for sharing all of this with us, and I'm so glad that you are safe and sound.
Thank you.
Oh, hello there. Has this presentation inspired you to learn as much as you can to survive in the wilderness in case of the apocalypse? If so, purchase the one and only Nature Pen. With this pen, you can apply your own natural dyes, and it is made of 100% natural tree bark. Its small, compact size allows you to carry it with you at all times, so that if you ever need to write a letter for help, you can do so quickly and effectively. Call our hotline on your screen right now to purchase your very own Nature Pen in 2 easy payments of $19.99. Shipping and handling is not.